again, welcome. Thank you all for being here. Thank you to all of our presenters today. I'd like to introduce you to our moderator for the day. Ben Nobuo-Berman is our the Urban Forester and Forestry and Natural Resources Advisor with UC Cooperative Extension, serving both Orange and Los Angeles counties. And Bea, I'll leave it up to you now. Turn it over.
Thank you, Jen. And when we're doing a round of applause, also thank you, Jen, for all the hard work that you put into this. And yeah, and Jen have been working really hard for this. So.
Okay.
Well, welcome everyone. So we're gonna have our first speaker for our keynote speaker. We have Max Moritz. He's a fire ecology specialist at UCCE, and he will talk to us about wildfire risk, long-term recovery, and climate projections. So Max, if you want to take it away.
Thank you. So can you see my screen?
Yes.
Yay. It's amazing when things work. Well, thank you. I guess I'll echo everybody else's thank yous to the organizers for putting this together and for having us give these presentations, and in particular, thank you for inviting me to give the overview first one. I'm a cooperative extension specialist, UC Cooperative Extension Specialist in wildfire, and I'm located at UC Santa Barbara. I've been doing this for, I've been a statewide specialist for 18 years, and what I'm gonna talk to you today about is some research updates and what we've learned about fire and climate change, and how we think about it, how we model it, and what we've learned from that we can actually hopefully apply to decision making, because that's really in a post-fire recovery world, which seems to be the norm now, adaptation, trying to learn from what we're experiencing and what we're finding in our research and applying it in meaningful ways is really the hope, right? So and with that, the start off slide here has a couple of images that don't seem to go away. The top one is from a burning home in the Angora fire around Tahoe about 15 years ago, and then the bottom is from the Camp Fire, Paradise, just a few years ago. And my talk is going to circle around to try to address some of these issues where fire ecology really meets where we live. Now, assuming I can change slides. Okay, so if you have heard anything about fire in an academic sense, you've probably seen this fire behavior triangle. And this gives us a way of thinking about how an individual fire is affected by different influences and how it will behave. So by behave, we mean flame lengths, rates of spread, heat release. And the drivers of those characteristics in a given fire often fall into these three categories. Fuel, so the amount, the condition and structure of the fuels that are burning. The topography, how steep the slopes are, in particular, because fire travels faster uphill. And then weather, specifically temperature, wind speed, and humidity, because those all affect how quickly and how hot a fire burns. Now, this is great for an individual event, but if you're thinking over longer time scales and larger spatial scales about how fire works on a landscape and how you might deal with it, some of us think more in line with this graphic. This is just a single image, or rather a single year's worth of fires marching through the months. I don't know if you can see the red highlights on the months down below, but this, when satellites first started giving us data sets like this, and we realized that this is how fire was operating across different planets, or different environments, not different planets, different environments across our own planet. It was sort of an eye-opener. We had a new way of understanding where fire occurs frequently, where it almost never occurs, and we were able to start to ask more detailed questions about why, what drives this process, and how that might inform our thinking about what's to come under climate change. So this is a more longer term cyclical biogeographic look at fire. And what we learned is that there are three basic bins of controls on cyclical fire activity. One is something about the fuels, the productivity in particular, how fast are fuels accumulating, and what are the environmental variables that are driving that, because that's really what limits the resources to burn on a given landscape. The variables that drive the fire season. So even if you do have fuels on a landscape, you have to have a window in time in which those fuels or that vegetation becomes fuel. It actually becomes flammable. And so a set of variables that control the fire season. And then ignitions, right? In space and time, you have to have ignitions coinciding with these other two sort of key factors to give you fire cyclically, different kinds of fire, but different fire regimes operating across the landscape. Now, back when we started trying to model this, the conventional wisdom was that climate change was probably going to make fire worse, right? 2006, there was a very prominent paper in Science by Westerling and colleagues looking at higher elevation western forests in particular, and showing that warmer springs, and that's what this bottom graphic here, the black line is spring temperature, and the red bars are area, or rather fire frequencies, the number of fires. And they made a very convincing case that warmer springs were leading to earlier snow melt and an earlier start to the fire season, a longer, more severe fire season, and increasing fire activity. And this was a harbinger in a way of many, many, many studies to come. But one of the things that we were left wondering is, even if this works in our higher elevation western forests, what about all the other forests? What about our oak woodlands? What about shrublands? What about grasslands? What about other parts of the world? What about Sahara Desert, about savannas? Coffee isn't quite kicked in, obviously. Other biomes of the planet. And we set off to figure out how the future might look different from the past. One of the things that we noticed, and it was evident just from that image that we saw, that global image of fire activity a little while ago, there are some places that are very suitable for fire year in, year out, and there are some places that are very marginal, that are you almost never see fire. And there are ways of thinking about this, right? There's probably environmental constraints on fire that lead to more suitable or less suitable conditions. And if you're an ecologist, this looks somewhat like a niche. And it turns out that habitat suitability modeling or species distribution modeling a decade and a half ago was starting to become very popular. People were using this to look at how climate change was going to impact extinctions, range shifts of different species, and extinction probabilities. And it turns out that it was a very useful framework, both theoretically and statistically, for looking at how fire might change across the landscape. So we set off for a whole series of papers looking at this. One of the first attempts was looking at global distributions, because we had these new data sets from global satellites that we could look at where fire occurred frequently and where it didn't. And then we could make projections finally. We could understand from these patterns of where fire occurred frequently versus almost never, we could understand what the constraints were in a given environment, what the variables were that were affecting productivity and fuel accumulation, what the specific variables were in that particular part of the world that were driving the fire season. And ignitions were actually found to not be limiting at very coarse scales. And we were able to model future fire activity. And so one attempt is to say, take a couple of dozen future climate scenarios and take the mean future fire activity from all of those and look at that another way. And that's what we're seeing here. Just an example of that in the near term, which we're in now, well into that. And then the far term, where pronounced patterns become more evident. And then another way is just looking at model agreement, not taking the mean change of all of the models, but just seeing how many of them even agree on the sign, whether there's going to be increasing or decreasing fire activity. And similarly, in the near term, we see some change, a lot of uncertainty, this gray area in the near term, because the models, the GCMs, the global climate models, they disagree so much. In the near term, there's actually a lot of uncertainty about whether fire is going to be increasing or decreasing. And then as you go farther out into the future, patterns become a little more clear. We've learned a lot since these early projections about what is important and what to include. And I think if we were to redo these today, we'd see some big differences. So as a framework for thinking about this, we sort of learned that there's this first order gradient of productivity, NPP, net primary productivity, and that fire frequencies respond to that in a very predictable way across the planet, across California and beyond. And that in this region where you have very low primary productivity, you have one set of variables that might be driving the system more, primarily things that result in the availability of fuel over the short term, and where fuels are more abundant, less limiting, you have another set of variables, often those that affect the length and severity of the fire season. But this set of controls and this framework of varying constraints is one of the things that came out of a lot of this work. And we now often use this fire regime triangle as a way to think about those three classes of variables or constraints on fire, and which one might be limiting as climates change. Now, when we zoom in and start to look at finer spatial scales, and specifically, say for California, here's an older image of the Jepsen ecoregions in different colors of California. And the orange splotches are about a 50-year span of fires. If you want to use historical patterns of fire on a landscape at this scale, and instead of, say, 50-kilometer grid cells, you're down to about 1 kilometer grid cells, and use this for decision making, you run into a very different set of issues. You still need very good climate projections, and that's one problem, because we don't really know which future we're going to experience, and we have a couple dozen to choose from. But the other is, as you get to finer and finer scales, you can't leave humans out of the picture anymore. You can't just use the variables that drive productivity on one hand and the variables that drive the length and severity of the fire season on another, because people have been sprinkled all over this landscape, right? This is an image of our power line infrastructure as just one example. But other examples of anthropogenic variables that need to be included are the road network, distance to public versus private lands, the housing densities. And all of these variables turn out to be really important to include in our fire models to predict fire activity. Because at finer spatial scales, humans actually have a strong influence on the landscape. And this has sort of forced us to think more of the problems and the solutions on these landscapes as coupled systems, right? Coupled human natural systems or socio-ecological systems. And this is just one diagram kind of showing the coupling of this. On the top, we have our natural landscapes and their natural fire regimes and all their variety. And then in the bottom loop, we have this human communities, right? Because we live on these landscapes, and where we interface with those natural landscapes is the WUI, the wildland urban interface, which has emerged over the last decade as one of the really thorny, difficult, and important issues that we're trying to tackle when it comes to fire. So what did we learn from these finer scale studies? One thing we learned was, from a modeling perspective, you can actually break the variables into two sets. One, the biophysical or natural contribution, the influence of the natural environmental variables on fire activity. And that's a map here we see from low to high, the sort of the sensitivity of fire to those biophysical variables. And then we can also look at the sensitivity of fire activity on a landscape to those anthropogenic variables, right? The road network, the power line corridor, the housing densities. And we actually see a really interesting set of patterns here. One is that human influences can push fire activity up, and that's the reddish patterns here, or down, those are the greenish patterns. That it basically has a predictable but also somewhat hump-shaped response. And this is an image from a very recent paper. Actually, this has been published. It's no longer in press. I apologize. But this is on the y-axis, the strength of this particular variable, mean housing density, here on the x-axis. And it basically tells this story that on very low development landscapes where there are very few homes, you have some background level of fire, and as you increase the housing densities, you increase fire activity, right? More ignitions, more people in the landscape. And then as you continue to increase that development, you start to go back down until you're in a very urbanized environment out here, like 250 homes, say, per kilometer squared, I believe is the units here. Where you're in a downtown LA or San Francisco or Sacramento, you're in an area where you don't have wildfires anymore, right? So this predictable pattern of how urbanization or human development affects fire activity was really an important finding in this work, and it shows that without good future development scenarios, just like we have many future climate scenarios to work with, we need a suite of reasonable future development scenarios so that we can actually make these projections and look at what might be coming in the future. But we don't have those in general. And it forced us also to sort of look at that fire regime triangle and the resources, conditions promoting flammability, and ignitions wings, and break them into both the human and the natural influences on those to help us get a handle on what's happening and what we might be able to do about it. Again, another example of how humans are driving our fire hazard, for one thing, right? Here's from the Bay Area. This is an image out of one of the California climate studies. Here's the natural effect, and if you look at the human effect, human development pushing fire up or down, depending on where you're talking about. So it shows us that human development affects our hazard, the fire activity on the landscape, but also where we put these homes affects our exposure and our vulnerability, right? That is a big, important lever, a policy lever that we have. We have through land use and urban planning, we have a way to affect not only our future fire activity, but also how exposed and how vulnerable we may be in that future. Who's using this? Well, CAL FIRE, for one, is using these fire probability maps to assess different fuels reduction projects for avoided emissions from wildfire. They're also using these potentially for the update of the new fire hazard severity zone maps for California, which guide building codes. And so just before I shift gears, there's some very real applications of these maps. So one of the issues that I often run into, and this is sort of my, shifting a little bit more into the extension role, is trying to communicate these these problems and solutions to the wider public, to legislators, to homeowners, to the media. And I often run into this problem that we think of the wildfire problem as a monolithic thing, as one issue. And that's an overly simplistic way of viewing things. And until we have a more nuanced, finer understanding of what it is we're trying to fix, we won't be making a lot of progress on that. And as an example, here's a narrative that I often run into that sort of exemplifies this problem. I often hear, hey, you know, there's a lot of talk of climate change, increasing fire activity, and you've even been involved in this, and that's going to make us put us in an even worse position that we're in now. And I'd say, yeah, there's good scientific evidence for that, not just from my work, but from lots and lots of other people's good work. Well, that's probably going to be more fire and more severe forest fires. And I think that there's a lot of good evidence for that too. Most of us studying these issues would agree. Well, that's probably going to lead to more home losses, right? In our built environment. And I think this is where many of us would stop and say, well, hold on, you know, let's be careful here. How we're making these links. But the narrative continues that, and with more, you know, climate change, forest fire, home losses, we're even going to have more of these disasters, these urban conflagrations. And again, I think many of us would say, you know, let's be careful here about how we talk about this particular issue, because is this really a causal chain of events and impacts? And I think I would argue, as with many others, that there's some things we've learned from looking at post-fire environments, especially in home loss situations. And if we were all in the same room, I'd try to get a show of hands, but you know, there's something that's similar here between these two images that's a little bit unusual. And it's not just the devastation. It's that in these two images and in many like them, the plants, the trees and shrubs around the homes are still unburned and green. And you see this over and over in many home loss pictures in many neighborhoods that have burned, that it's not necessarily the trees right adjacent to the homes that have ignited them. It's embers coming from relatively far away in a high wind, often situation, that have ignited homes, and then the homes begin burning. The homes become the fuel, and the homes generate their own embers and heat and ignite neighboring homes. So the idea of climate change leading to more forest fires and then the adjacent forests burning these homes. Well, most of these homes are burning because of embers, often from other homes burning in high wind situations where the forest may be very far away. And actually, most of the home losses are not really even in traditional forests, right? These are not your mixed conifer forests systems that we often think of. So I think it's worth recognizing that we have a couple of key issues here that we're dealing with. One is that forest losses are real in the face of more extreme droughts, pests, fires. That is a land and forest and fire management problem, and that's a very serious one out in our wildlands. And we have a home loss problem in our wildland urban interface. This is not a forest fire problem, but one of where and how we build our communities, one of urban planning and design. And it's a very, very different set of problems and a very different set of solutions to address between these two basic issues. I spent some time going a little bit outside my comfort zone as an academic, but realizing there really isn't that much out there on how to do better community design in fire-prone environments. So I worked with Dan Butzik, a colleague, for a couple of years, trying to figure some of these issues out, interviewing fire professionals and planners and looking at the research from our own academics and those from other countries, particularly Australia, and came up with some guidelines, some helpful risk reduction measures. And I'll walk through a couple of those here. One very basic one, it's harder to put into practice, but basically avoid building on the most hazardous parts of a landscape and concentrate development, hopefully the same number of homes in the lower hazard portions of the landscape. This is similar to using floodplain maps or flood maps to guide building in flood-prone environments. There is precedent for this in Gaviota Coast Plan here, the second sentence in the center box. Building sites should be located in areas of a parcel's lowest fire hazard. Now, there are fire hazard maps that can help guide this type of decision making. And this is one very simple and commonsensical way to proceed. Concentrate building of homes on the inner side of perimeter roads on developments. I had a fire marshal point out that he requires this of all development in his county. Doesn't always go as planned, but this provides, instead of having homes on this outer ring whose backyards are all exposed to the wildlands and fire, you have a full sidewalk, street width, sidewalk and yard before you get to a structure, providing a very large buffer of defensible space. Cluster structures and use non-flammable community amenities. And a very obvious case of this would be, instead of in a new development putting the homes around the golf course, put the golf course around the homes, right? Another cartoon kind of depicting this idea. Here's a traditional gridded older neighborhood on the right-hand side of this image. And then as this suburban sprawl-ish type development has happened, it has eaten up a lot of this hatched landscape, which is supposed to be farmland. We have more and more lower density homes that are spaced out, harder to defend from a firefighter's perspective. And we've eaten up a lot more of this darker native landscape, when in fact we could have clustered development that is more buffered by this existing ag, which actually does provide a very good fire buffer. Same number of homes, less natural landscape, less natural habitat eaten up. And this idea of buffering as we move forward is also a way to proceed. So I'm going to wrap up here, leave some time for questions. I hope we do have, for existing communities, the idea of just a massive mitigation effort, right? Both on the built environment, the communities, the people, and the natural landscape. There is something now called a regional wildfire mitigation program. It's sort of a spin-off from the CWPP, the Community Wildfire Protection Plan idea. We've started one here in the Santa Barbara region. So if you go to RWMP, Regional Wildfire Mitigation Program, rwmpsantabarbara.org, or if you email me, I can put you in touch with that. It's a new program to map and assess the risk and prioritize all of the mitigation activities. It's funded at $2 million right now, but I think it provides a model for existing communities to move forward and have some hope. With that, I'd like to turn it over to, or turn it back for hopefully a couple of questions if there's time, but also to the next speakers who are going to be talking about recovery on post-fire landscapes, soils, and vegetation. And I think it'll be an exciting day or exciting morning. And again, I appreciate the opportunity to be here and talk to you. Thanks.
Thank you, Max. That was a great presentation. I really appreciate it. We do have time for a few questions if people want to put that in the Q&A box. So maybe we can wait a couple of minutes if people have anything to add in there.
Stunned in the silence.
No, I think this was a great way to put us all in context in what we're going to be talking today. While we wait, if someone has any other questions, we can start getting our next panelists just start getting ready. We did get one question here.
Yeah, how do coast live oaks fare? It's a good question. I'm not the best person to answer that, but coast live oaks in general are one of the oak species that have relatively thick bark, so they're fire resistant to a certain degree, but often the foliage, when it is burned, they resprout really well. So they're one of the trees that is pretty well adapted to that.
We've got a couple more questions. Laura Eisenberg asks, what are your thoughts on the value of fire-wise communities as part of the solution?
Great question. So there is a lot of hope. There's a lot of hope that programs like Firewise in particular is one of the few that is recognized by a handful of insurance companies that will offer a small reduction in your rates if your community is Firewise recognized. I think it's a great idea. In Santa Barbara, for our regional wildfire mitigation program, we have several dozen communities that are all being mapped and organized, and all of them are going to be trained and plugged into the Firewise USA program. So we have great hopes for that, and I think it is a great program.
Bea, do we have time for one more question?
Yes.
Valerie Zara asks, in the guidance, is there anything that helps to recommend protection of riparian habitat?
Nice. Well, that's a tough one. Riparian habitats in many landscapes are the ones that have the highest foliar moisture and the ones that actually burn the least, right? In many post-fire shots, you see the riparian ribbons as the lone green holdouts, except on very, very fast-moving, wind-driven fires. Sometimes you'll see damage to the riparian areas, or in drought years. So I think the one thing that we can hope for is if the riparian area truly is sensitive, you could imagine doing some fuels work adjacent to it, doing some prescribed burns adjacent to the riparian area. Or in a way, you could imagine working with water such that you could return some of the water to certain parts of the landscape to keep creeks flowing and keep riparian areas greener and more as a buffer against fire. I think both of those strategies are good.
All right, so thank you so much, Max. I think there's a couple more questions coming in, but maybe we can answer those in the chat. We're just gonna continue with our program. Thanks again, Max. That was great to hear from you.